Welcome everyone. This is DEE401 Analog and Digital Circuits, and now we will continue our discussion on differential amplifiers. And here we will try to understand why the inputs of the differential amplifiers are called inverting and non-inverting. The one input is called the non-inverting and the other one is called the inverting input. So in order to understand the inverting and non-inverting feature of the inputs, we will have to do some AC analysis. Here I will not perform the complete AC analysis, as I already told you this is not in our syllabus. So some steps of the AC analysis I will use, and with the help of that we will try to understand why one input is called the inverting and the other one is called the non-inverting. Okay, so let us start the analysis. I hope the mathematics of the signal which we have discussed in the previous session is clear to you. This is just the basic mathematics, or you can say the geometry of the signals. Now, in order to find which input is inverting and which input is non-inverting, we will use the superposition theorem, because first thing is this: in order to apply the AC, apply the AC analysis on this circuit, what is required? What is required? The DC sources must be short circuited. So if the DC voltage, if there is a DC voltage source, then it must be short circuited, or if there is a DC current source, it must be open circuited. So here we have two voltage sources. So this is short circuited, this is this is grounded, this is grounded, and both the sources are grounded. And now we will perform the AC analysis. So in order to perform AC analysis, yes, we will use the superposition theorem. So because we have two sources acting on the differential amplifier, we will see the effect of one source at a time. First we will use this source and we will try to find out whether this is a inverting or non-inverting. Already it is written here this is non-inverting, and here now we will see how this is non-inverting, and then we will apply the another source, and then we will try to find out whether this is inverting or non-inverting. Okay, let us start our analysis. So if I provide the input is like this for this source, if I provide input is like this, because by the DC analysis I have already chosen the value of RC and RE, and now I am using the superposition theorem and I am grounding this source, and I just wanted to see the effect of this signal on the circuit. And one more thing I would like to add here, there is a remark 5 after the video 1, and in that remark 5 some students have some kind of confusion. So that remark will be also cleared by this concept. So that remark says that the emitter is of the both the amplifier, this amplifier Q1 and Q2 are connected. That is why the effect of one signal is on both the output. So we will see how the one signal will affect both the outputs here. Both the output will be affected by the one input. Here we are using superposition, so we will deal with the one source at a time. Okay, let us start the analysis. Now if I have applied this input here, the input is like this, so so we are feeding the base, and we are taking output at the collector, and we know that for a common emitter amplifier there is a phase difference of 180 degree. There is a phase difference of 180 degree in the output and input. There is a phase difference of 180 degree in the output and input. Now the output is like this. Now if you remember the concept of emitter follower, so whatever signal is applied here is in the same phase on the emitter. We know this thing. If we are taking output from emitter, and this is the basic concept of emitter follower, this drop is zero 0.7, so whatever is applied is coming to the output, just this drop. That is why we say the voltage gain is almost unity. So by recalling this concept of emitter follower, whatever is applied at the base, and if we are taking output from the, or we can say if there is some signal on the emitter, will be in phase with the input. So this concept we will use here. Now this Q1 is the common emitter amplifier, and the input which we are feeding at the base is providing a out of phase output at the collector. Now what is happening at the emitter terminal? Here this signal will be like this almost, because if this, because these both are connected, this signal will go through this signal will be here. Now the Q1 is a common emitter amplifier. Now for Q2 the base is common, we are not applying anything at the base. Here this signal is coming to the emitter. It means the emitter is getting this signal, so at the output there will not be any phase inversion, because this will act as a common base amplifier, because base is common, and we are getting a signal at the emitter. Base is common, so the output here will be in phase. So this is how we are getting the output. Now if this is C1, we are getting this, C2 we are getting this. The output is taken as C1 plus minus, so this is C1 like this, minus this, and minus of this is plus of this. So this plus this equal to this. So we are getting the output is like this when input is this. And this is of the same frequency. Actually the drawing is not good enough, but the frequency is same. The input is this and output is this, so there is no phase change in the output. So that is why this terminal is called non-inverting terminal. Again I will explain you. We are providing the input here, the input is we are feeding the base, and we are taking output at the collector. This and there will be 180-degree phase shift in the output and input, and output will be like this, and this emitter signal will as the both emitters are connected, that is why this emitter signal will go through this here, and here it will act, this transistor will act as a common base signal, and the output will be like this. It will be in phase with the input. So the Q2 is working as a common base emitter. So this terminal is the, and this is just the geometry of signals, and this is how we are getting the output which is in phase with the input. Now we will try to understand the inverting terminal. So for the inverting terminal, this terminal is grounded, and we will provide the same signal here, the same kind of signal here, and let us try to do the same analysis. So now this will be very easy. Q2 will be working as a common emitter amplifier, Q1 will work as a common base amplifier. Q2, the output will be like this. Q1, and this signal for this emitter, the signal will go like this, and this signal will be in phase. So now this is C2, this is C1, C2 is this, C1 is this, and by the geometry I can write this, and this is the geometric sum of these signals. So we are getting this signal at the output. We are getting this signal at the output, and we are getting this signal at the output, and the input which is applied here is this is this. So here we find there is a phase shift, between input and output. So this terminal is called non-inverting terminal. So this is the last concept of the differential amplifier which is in our syllabus. I hope this is clear to you. If there is any doubt, you can directly mail to me, sumitdei1729. In case if anyone is not familiar with my email ID, sumitdei1729. अभी तक जितने भी डाउट आए थे मेरे पास, मैंने सभी के आंसर करने की कोशिश की है, एंड आई होप आई हैव गिवन द आंसर्स. बाकी वी विल स्टार्ट विद द ऑपरेशनल एम्पलीफायर. आई थिंक आज शाम से या कल से हम स्टार्ट करेंगे. अभी इसके साथ में मैं मॉक्स के नोट्स और प्रोवाइड करूँगा अपने इस चैनल पे, तो आपको मॉक्स के नोट्स भी मिलेंगे अभी. after uploading this video, I will provide the notes of mocks. Okay.